Hey, what's going on, guys? Back again here. In this video we're going to be generating pre-calculated king attack bit board. So let's have a look at a king at the square of d4, and now I just want to use these black pawns to flag those squares that are actually attacked by the white king. So all the squares where the king can go, basically. Obviously the attack table itself would look something like this, because the king itself obviously won't be shown there. And if, say, we just try to move the king one square to the right, it would be like this, and if we just move this one square to the right, it would be something like this. And also, if the king, assuming the king is in the corner, we'll have only this attacks being available here. So our goal is to generate these attacks using the king move of stats, and also take care of king step and off board, because let's consider the king stands right over in here, that we can encounter an issue where king captures off board and the attack bit appears to be on the next rank, which is absolutely wrong, basically. So we'll take care of this as well. So I hope now it's quite pretty clear, well at least visually, what we're supposed to be doing in this video. And now just close my arena and go back to the source file that has some pre-coded stuff already. So basically this is the code from the previous tutorials containing pre-calculated attacks for pawns and knights. But that's not the point. The main thing here, we have this definition of the U64 unsigned long type, also known as a bit board. We have the very basic bit manipulation macros to get, set, and pop bits. We have our board in the end is definition with the square mapped accordingly, definition for our sites. We have a simple routine to print the bit board in binary representation in the format of 8 to 8 table, which is quite pretty handy during the debugging process. Here we have some constants to bitwise and our offset attacks with, in order to take care of pieces capturing off board, what I was just talking about. So for the most likely for pawns and kings, these two, and these two are used for knights, because knights are kind of jumping over the square. Also, here we have the arrays for pawn attacks for white and black pawns, and 64 squares means, like, bearing in mind that the pawn might be on whatever of up to 64 squares, and we need to generate the attacks for pawns on whatever square. Same for knights. And here we have the functions initializing the pawn attacks and the knight attacks, and the function that initializes actually these attacks using the mask functions here. So in this video we'll start straight ahead from generating our moves for our attacks for a king. So the very first thing I would like to consider here would be to define the king attacks array and square. So this means that we have this U64 and standalone bitboard king attacks, and this is the array of up to 64 bitboards representing the position of king of every single possible square on board. So starting from A1 and ending up with H8. Okay, and also we need to define our mask king attacks, just like we've done here with the knights. So I can simply say, like, mask king attacks, and this would be the U64 function, and mask king attacks, and it would be taking the square, right? Yeah, the square as an argument here. And let me just grab things that are all the same for. Oh my god, guys, I'm sorry, just my phone wants something from me. Hold on a sec. Okay. Oh, I got a new subscriber. Cool. Okay, let me just put it away. Okay, so here we need to define a couple of variables. So the first is the U64 attacks, which is the bit board preserved to represent the attacked squares by the king that would eventually be returned for every square that we can send as an argument to mask king attacks. Also, we have this temporary bitboard to make use of in order to calculate the particular attack offset and to make some tests to make sure that the attacks are on board, so kind of things like that. And obviously we're setting the bit that is represented by the square that we're taking as an argument with our masked king attacks to put to place an imaginary king, let's say, to this sort of a bitboard. So I'll now just demonstrate you how it works. It's quite pretty simple. And the very last thing to consider here, we need to return attack map for king on a given square. So first I just want to print bitboard, and this bitboard we would be setting up our kings. So I don't really need this stuff for a while, so I can simply call this mask king attacks, and I want to set the king on the square, let's say d4. So now we need to open the terminal in the current working directory, compile and run the source. So in order to do this, I need to say gcc bitboard.c-o bitboard, and if it compiles I would like to run the bitboard binary executable. Let's have a look. Okay, so you see, like we have this 1 on the square of d4, which means that we just successfully did set up the king like on this square. So from now on, well, I'm not going to be showing you this anymore. Instead, we would be working with an attacks. So I don't really need this stuff anymore. And here we want to generate king attacks. And now first we'll start providing the offsets and then taking care of the condition of not going off board, not attacking off board. So let's say attack bitwise ord with bitboard, where we just set our king on and we want to right shift. So we'll have the offsets of just say d4. So that would be the offset of 1, of 8, 9, 7, and yeah, and basically this is it. And the rest would be just in the opposite direction. So let's start defining these attacks basically. So let's start with let's say right shift to let's make it the right shift to 8 to make the king going upwards and downwards. So also now instead of just calling this function, I want to say print bitboard, because the mask king attack would return a U60 standalone U64 data type, which is the bitboard. So we can already use that as an argument for our print bitboard function. Okay, I forgot the semicolon somewhere as always. Okay. Oh, attacks, save. Okay, so assuming that our king is set up on d4, we now have one possible attack to d5. And now if we just move king on d8, let's say, it won't be really capturing off board, but the problem is that still kind of this the attack is not on board. So in order to avoid this sort of a behavior, we need simply to say here just if, and this bitboard right shifted to 8 is equals to true, because otherwise let me just try to show you what is gonna happen otherwise. If we just print let's just print this as a decimal, or yeah, we can actually print this as a bitboard as well, I guess. That should be I'm not sure. Okay, let's try to print bitboard first. And if it doesn't work, just want to have a look at the decimal number. So yeah, I'm not sure which one. So let me just get rid of this one. So you see, like, oh, I still need to call this. Okay. Oh my god, what have I done? I've just git cloned my. Sorry guys, just the wrong command here. Just hold on a sec. I didn't mean this really. Kin attacks. What have I done? I just git cloned one of my chess engines here. Didn't mean that. Sorry. I meant to compile and run the source. Okay. So yeah, we have this bitboard equals to 0, which means obviously off board. And if we just put this on, say, D7, in this case we have a positive number. So it means, anyway, it means true. It's not, doesn't mean 1 obviously, but it means true. So only if the bitboard equals to true, in this case we just make sure that the attack square is on board. So that's the reason actually to providing this sort of a condition here, is to make sure that it is actually kind of on board. And now we can also make the same for, well, probably I would make it later on, or well, I can actually, let me do this just right now. So for the opposite direction basically, so here and let me just, okay, and now if the king is on D8, it doesn't obviously go in upwards, but it can attack downwards, which is also good. But if we just put this on D1, that would be the only attack that is going to D2, which is exactly what we need here. Okay, so let's drop back our king on D4 to have both attacks simultaneously. And now let's handle the offset of attacks, bitwise or equals bitboard right shift to 1, and it would be now probably attacking to the left if I'm not wrong. Yeah, now it acts to the left. So now let's try to move the king to, let's say, B4, and everything is still fine. But if we just move our king to A4, it turns out that it captures on the H file, which is horribly wrong. So in order to avoid this behavior, it's literally enough to say, like, if and bitboard right shift to 1 bitwise end with not H file. And I will now show you what how does the not H file constant look like. So here it is, not H file. So this is the decimal representation of this constant. So we just bitwise end in our attack bitboard with this constant number, or in binary this looks like this. So if anyone would come here after this bitwise end, it would be resetted to 0. It would get it would reset to 0 that bit. So, and it won't be capturing on board anymore. So let me just show you how this is gonna look like. Okay, did I forget? Okay, just forgot to save. Okay, so now we're not capturing on the H file, which is quite pretty nice. So now let's drop back to D4. Okay, and by the way, the same issue would be for if we just go for I guess 7 or 9. Let's see, I'm not sure. So if we have attacks bitwise or equals with bitboard right shift to, let's start with the 7. Just okay, and let's, in this case, let's consider 9. Oh, that's just a matter of I guess, or no. Okay. Okay. I'm just wondering. So this one would be -7, I guess, or I mean left shift 7. Yeah. Okay. So let's right shift 9 here. So if we just now put our king back to A4, the same disaster would happen. So it tries to capture an H file. So in order to avoid this, we're doing literally the same. So we need to make sure that actually if our bitboard right shift 9 bits is bitwise ended with not H file actually equals to true. Otherwise it would be equal to false, and we're not gonna be bitwise or in our attacks. So okay, now it has disappeared successfully. Okay, so we have 1, 2, 3 up to 4 attacks here. Okay, anyway, we need also to take care of this attacks bitwise word with bitboard, oh my god, right shift to the 7, and in this case, okay, so it captures here. I'm just wondering, oh, it's not yet capturing here because it's not capturing yet in the opposite bit shift. So let's now put our king on H4, and it should overlap on A file, right? So in order to avoid this sort of a behavior, we need to say if and bitboard right shift to 7 not and not A file, like this. So now this should work properly. And just wondering, so 1, 2, 3, 4. So now we need to do the same for the opposite directions. Just want to make sure that I'm not gonna miss anything. So change the direction of bit shifts, and the offsets are remain the same, obviously. And as far as we did change this direction, we also need to change the file to bitwise end with. Okay, so now it seems more or less just fine. So I will now quickly test this manually, and then we'll go for initializing our king attacks, so to make sure that everything is working properly. So let's try to move the king on D4. Okay, now let's move it to A4. Make sure, okay, no overlaps, no board captures. Perfect. Let's move it to A1. Okay, to H1. Okay, good. And now let's move it to A8. Okay, and to H8. Okay, it seems like working quite pretty nicely. And from now on, we can actually add our king attack initializations within this pre-calculated attack tables for leapers function to initialize all the leaper attacks, basically. Okay, I'm just wondering, we could later on probably add the sliders here as well. Well, I need to think about this in some spare time. Okay, so king attacks and square. So here we enter the loop of from 0 to 64, so we literally loop over all the available squares on board, and we need to mask our attacks for king. So mask king attacks for every possible available square out there. And the very last thing to consider, we actually need to test this. So again, I make this loop over 64 squares, and I want to print this king attacks for every single available square. But before this, I just want to clear my console. Okay, and now I can run this again, and here's what we got basically. So the king is moving from one square to another, so we have the pre-calculated attacks for a king on every single given square. So now it goes to h2 on the board. So you see, like, we got the king attacks for every single square possibly available. So let's have a look at the very beginning here. Okay, hold on a sec. Okay, hold on a sec. I'm slightly confused with what is this basically. Hold on, I just don't get it really. Well, now it goes quite pretty nicely, but what the hell is going on here? I'm a bit confused. So hold on a sec, I can't get it really. So king attacks at index of 0. Well, this is right. Well, so what the hell is going on? Their index of 1. This is right. Okay, index of 7. Okay, index of 8. Next rank. Okay. Maybe I just was watching some run output. I have no idea. Oh, okay, just square. Brand king attacks. Okay, let me just clear this a couple more times. Okay, and run this stuff. So here it looks perfectly well, but what the hell is this? I mean, like, what is this? What is it printing here? Oh, maybe, hold on, my mask can't. Yeah, I'm just printing this bitboard. Oh my god, what have I done? Obviously I shouldn't ever be doing that. So let's clear again, and yeah, now it makes sense to me. So yeah, obviously starting with the A8. Yeah, I was just printing the king square as well, which is obviously not what we need here. Yeah, now it clearly shows us that the king attacks has been initialized correctly. Well, okay guys, so this is it for this video. I hope you've enjoyed watching and possibly following this. Thanks for watching basically. The next steps would be to generate attacks for leaper pieces like rooks, bishops, and the queen attacks would be combining the rooks and bishop attacks, obviously. And then we'll go for quite pretty complicated and sophisticated topic of generating, not generating, but initializing pre-calculated attacks for sliding pieces, which also need to take care of some possible occupancy on board, and there are really lots of variations gonna be there. And I'm also going to create some theoretical video, because it would be a little bit too difficult to just jump straight ahead without a prior understanding of what exactly we're supposed to be doing there. I will first obviously test this on my own, and then I will definitely share this with you guys. So this is it from my side. Thanks for watching.